the Pakistan, Bangladesh, Nepal, and other countries. So today we'll discuss about the liquid waste management in the hospitals. Can you see my next slide, please?
No, sir.
Can you see now?
Yes, sir.
Okay, then we'll go ahead. Therefore, today we'll discuss about the liquid waste management in healthcare facilities. And before you go, you should see where the content of the my presentation would be what requirement in healthcare facilities, what is the source of wastewater generation from healthcare facilities, what are the characteristics and hazards associated with the wastewater from healthcare facilities, and what are the rules concerning the liquid waste management in healthcare facilities as per the Bangladesh Waste Rules 2016, and what are the treatment and disposal options for wastewater generated from the healthcare facilities which are available. You all know that various activities in the healthcare facilities leads to waste management, which includes biomedical waste and other waste, as well as the liquid waste management. Liquid waste is generated. Generally, in the hospital, as per the National Building Code of India 2005, the Bureau of Indian Standards, Class 4.1.2, water supply for buildings other than residence, there is a, and as per the manual on water supply and treatment of, as per the Ministry of Urban Development, March 1991 under, they specify that the hospitals requires various water requirement, which includes laundry. If a number of beds are exceeding more than 100, in such a case, they require water about 340 liters per day, per bed, I'm telling you. And if number of beds exceeding 100, they require about 450 liters per day. Whereas in case of nursing homes, medical quarters, and hostels per head requirement is about 135 liters per capita per day. LPCD means liters per capita per day or liters per head per day. Water demand for visitors generally is at least required about 15 liters per capita per day. This is the water requirement in case of hospitals. Therefore, generally, whatever the water is used, about 80% of water consumed is generated as wastewater. And therefore, if any person, any hospital is using 100 liters per day, let us say, then the expected wastewater generation will be around 80 percentage, means 80 liters per day. Therefore, depending upon the water consumption and the activity, the type of activity involved in the hospitals, the wastewater is generated. Before discharge of this wastewater has to be ensured proper treatment and disposal. Before disposal, you have to ensure proper treatment. Then only the treated water has to be disposed of, complying to the discharge norms prescribed under Schedule 2 of Barmer Waste Rules 2016. Now, what are the various sources of wastewater generation in healthcare facilities, which includes administration and wards, operating theaters and ICUs, laboratories, radiology department, hemodialysis, then dental departments, kitchen, laundry, and toilets, engineering and maintenance department. And apart from above sources, there will be water generation, runoff water, especially in the monsoon time or rainfall days. Runoff will be there from paved areas. Apart from that, the various wastewater is also generated like domestic sewage and culture, stocks, the associated biologicals, body fluids are also generated. And various disinfectants are used in order to maintain cleanliness of the hospitals. Therefore, used disinfectants are also is the type of wastewater from the hospitals. These disinfectants, various floor washings, including patient areas, also generates wastewater. Hand washings also generates the wastewater. Air pollution control equipment. If DG set is there or any steam boilers are there or any other equipment are there, wherever the air pollution control systems are adopted for control of air pollution emissions in the particular activities or from the equipment, then there will be liquid waste generation from the air pollution control process also. Apart from the discharge of accidental spillage may occur, which includes like chemicals, laboratory effluent discharges, fire accidents, etc. Therefore, these are the possible source of wastewater generation in healthcare facilities, and that you have to keep in mind. Therefore, these are the pictorially as shown various source of water is intensive care units, dental departments, radiology, hemodialysis, laundries, kitchen, administrative office, engineering and maintenance, laboratories, bathrooms, urinals, runoff from paved areas, which includes rooftop runoff, and also patient wards, surgical units, or operating theaters. These are the possible source of wastewater generation that we remember. What type of waste categories are there? The wastewater. One is, we call there are three types of wastewater. One is black water, second one is gray water, and third one is the storm water. Black water is nothing but the sewage, which is polluted in nature and containing high concentration of fecal matter and urine and food residues. Therefore, you will have the fecal contamination means generally you can expect fecal coliform, and food residues are there means naturally you can expect high BOD. And grey water is nothing but sludge, is a low polluted wastewater with residues from washing, bathing, laundry, or technical process such as cooling water, etc. We call it as grey water. And storm water is nothing but it is technically not wastewater, but consists of rainfall runoff collected from hospital roofs, grounds, and private surfaces. This storm water can be collected and used for the purpose of gardening or toilet flushings or groundwater recharge because they are not contaminated. Anything from rooftop surfaces can be collected, and this water can be used directly for the purpose of groundwater recharge, but not from other any contaminated surfaces. Therefore, these three types of the categories of healthcare wastewater can be classified into three types. One is black water, grey water, and storm water. And what type of wastewater contaminants will be there? We can expect from the healthcare facilities, the wastewater generated from the healthcare facility. We can expect the chemicals as a part of wastewater, which includes anesthetics, disinfectants like formaldehyde, glutaraldehyde, chemicals from laboratory activities, and photochemical solutions. Of course, these are very less nowadays. We have gone for digital. Photochemical solutions are available, and X-ray contrast media containing observable or halogen compounds. That is what we call it as AOX. Mercury from dental amalgam or lab chemicals. Nowadays, mercury-based instruments are not used in the healthcare facilities. Therefore, mercury as a part of wastewater is very minimal now. But for the purpose of in government hospitals, I hope so, only for demonstration purpose, mercury-based dental amalgams are used only for the demonstration purpose. Therefore, the mercury from hospital generation is I think so it is not at all there nowadays. Mercury bearing instruments are not used in any hospital. They are all gone for digital thermometers and digital sphygmomanometers. And excessive nutrients and nitrates will also be there as a part of the wastewater. Pharmaceuticals, including antibiotics, because of discharge of wastewater, the outdated chemicals may be discharged into the wastewater, into the drains that may become a part of wastewater from the hospitals, or because of the consumption of pharmaceuticals by the patients because through the urine and the fecal matter, there is a possibility of having the pharmaceuticals some residues. Radioactive waste are also possibility for discharge into the drain from the hospitals wherever this radiology department is there. And infectious agents, including bacteria, viruses, and parasites, generally will be there. It will be present in the wastewater generated from the hospital. Therefore, generally, the urban local bodies, they keep on examining the rainwater samples so that what type of the virus are there and possible the spread of diseases that may occur, that will be analyzed by the urban local bodies through drain samples so that they alert the healthcare department to take necessary actions. Therefore, the considering the contaminants in the wastewater, the wastewater generated from the hospital has to be treated properly. Then that treated wastewater only can be permitted to discharge into the drain so that it can go for further treatment and disposal. Therefore, wastewater from healthcare facilities requires proper treatment, and that what are the treatments available, and let us see. What type of categorization of liquid waste from healthcare facilities? Infectious waste will be there. There will be liquid contaminated with the blood products, body fluids. Liquid waste from oncology department, that means chemotherapeutic and pathology, formaldehyde, example, this sort of the chemicals also will be there. Photographic chemicals like hydroquinone, KOH, silver, glutaraldehyde from X-ray units is possible. Nowadays, they are gone for digital. Therefore, this sort of chemicals we cannot export from the. But anyhow, still some few chemicals may come, like glutaraldehyde also. Mercury from broken and obsolete equipment. Of course, these are also not possible nowadays because of most of the hospitals are gone for the digital based thermometers and sphygmomanometers. Nobody is using mercury based instruments. Only in emergency departments, I hope so, they may be using mercury-based thermometers and speedometers in order to have effective assessment of the temperature and the BP of the patients. And the solvents like the halogenic compounds such as methylene chloride, chloroform, trichloride, ethylene, and refrigerants, non-halogenic compounds such as xylene, methanol, acetone, isopropanol, toluene, ethyl acetate, and acetonitrile are generally these sort of the chemicals you can expect from the healthcare facilities. And what type of the you can categorize the liquid waste from healthcare facilities? We can you can categorize into two types. One is organic chemicals, and other one is as inorganic chemicals. Organic chemicals include disinfecting and cleaning solutions such as phenol-based chemicals, the perchloroethylene used in workshops and laundries, oils such as vacuum pump oils, used engine oil from vehicles, and insecticides, rodenticides are generally you can expect from the liquid waste generated from the hospitals. Inorganic chemicals such as which may contain mainly acids and alkalis, which includes sulfuric, hydrochloric acid, nitric acid, and chromic acids, sodium hydroxide, ammonia solutions, and also includes oxidants such as potassium permanganate, potassium dichromate, and reducing agents such as sodium bisulfate and sodium sulfate. These are the type of chemicals you can expect from the hospitals also. Apart from this, we already discussed that pharmaceuticals, small quantities of pharmaceuticals are usually discharged into sewers from hospital, the pharmacies, and from various wards, including antibiotics and genotoxic drugs. Other pharmaceuticals which have been detected in wastewater plant effluents include lipid regulators, analgesics, antibiotics, etc. These are expected the pharmaceuticals in the wastewater generated from the hospitals. And radioactive waste and nuclear medicines also is possible. Clinical testing laboratories, the wastewater is also possible in the liquid wastewater from the hospitals. Sewage generated from toilets and bathrooms also may contain residual pharmaceuticals because of urine may contain the residual the medicines which may also contaminate the wastewater from hospitals. Housekeeping activities such as in all wards such as the mortuaries, operation theaters, laboratories, which may contain phenol and cleaning acids, including soaps and detergents. Discharge from kitchens is also the possible liquid categories of as per these are all as per the WHO. And these are the contaminants in wastewater generated from hospitals, and I have given the form of the diagram, which you can see in your syllabus also. And what are the implications of discharge of wastewater from healthcare facilities? Therefore, environmental implications will be there. Excessive nutrients may cause biological degradation in groundwater, lakes, and rivers by using up oxygen, resulting in algal blooms and biotoxins. Therefore, if any liquid waste generated from hospital is discharged directly into the improperly, that may contaminate the lakes or water bodies. Definitely, this wastewater has to be ensured for proper treatment before discharge. And pharmaceuticals in where water may act as endocrine disruptors, and antibiotics could result in antibiotic resistant pathogens. Therefore, mercury and heavy metals may poison the water bodies. Therefore, the wastewater from healthcare facilities has to be treated, and then only the treated water has to be discharged in order to minimize the environmental implications. It may also cause the waterborne outbreaks in communities, which includes the hepatitis A and E. Therefore, other sort of the fevers like typhoid fever and this sort of waterborne disease also may outbreak in the communities. Apart from these, vector-borne diseases and parasites will be there like dengue fever, malaria, roundworms. These may cause these sort of the problems, which includes the environmental implications, waterborne disease outbreaks, and vector-borne disease and parasite problem may arise in case of the wastewater generated from healthcare facilities discharged improperly. Therefore, the main hazards associated with wastewater from healthcare facilities, hazards due to pharmaceutical and cytotoxic waste, hazards due to radioactive waste, and hazards due to hazardous chemical waste discharge as a part of the liquid waste from the hospitals, hazards due to microbial pathogens. Therefore, these are the hazards associated with the wastewater from hospitals. Therefore, we have to take into account for people. What are the hazards of microbial pathogens? Maybe waterborne disease, it may cause waterborne diseases. And if any the wastewater discharge that may cause depletion of oxygen in the water bodies, It also cause vector-borne diseases. It also cause the harmful chemical effect in the water bodies. Parasite infections, multi-drug resistant bacteria may develop in the water bodies. Therefore, these are the possible hazards of wastewater. If you refer to the Barmatic waste rules notified in the year 1998, the wastewater generated from the hospitals has been categorized as category number 8. I'm talking about 1988 rules. Okay. This waste, earlier they have suggested to go for disinfection by chemical treatment and discharge into drain. That is the method they have suggested earlier. And category number 10, like in a chemical waste, earlier in the year Biometric Waste Rule 1988, they have specified that you can go for chemical treatment and then it can be discharged into drains for liquids. This is about, I'm talking about the 1988 rules, but let's refer to the latest rules. If you refer to Biometric Waste Rules 2016, which are relevant to liquid waste management in healthcare facilities are there as per Rule 4C, pre-treatment at on-site laboratory. The pre-treatment on-site is required in case of laboratory, microbiological waste, blood samples, and blood bags by either by disinfection or sterilization, or as prescribed by the WHO or National AIDS Control Organization guidelines. If you refer to Rule 4J, which ensures, which stipulates that ensure segregation of liquid chemical waste at source and ensure pre-treatment or neutralize prior to mixing with other effluent generated from healthcare. That means all liquid chemical waste has to be neutralized as per Rule 4J. And Rule 4K prescribes ensure treatment and disposal of liquid waste in accordance with the Water Act. Therefore, whatever the liquid waste is generated from hospitals has to be treated in accordance with the Water Act 1974 and ensure treated wastewater is discharged. According to Rule 711, Sub-Rule 11, which prescribes that handling and disposal of all the mercury waste shall be in accordance with the respective rules and guidelines. But anyhow, the mercury-based instruments are not being prohibited, but in accordance with the Minamata Convention, all the hospitals slowly eradicate use of mercury-based instruments as per the commitment made by the Government of India in that Minamata Convention. As per, if you refer to Schedule 1, which under footnote, it says that residual or discarded chemical waste used or discarded infections can be disposed through hazardous waste treatment storage and disposal facility. Therefore, any chemical waste is there, that chemical waste has to be disposed of through a hazardous waste treatment storage and disposal facility, either directly or through the common biometric waste treatment facility, which is accessible to any hospital. Therefore, chemical treatment using at least 1 to 2% of sodium hypochlorite solution is suggested in case of non-bedded hospitals, and they have to use chemical treatment method before discharge of the treated water using chemical disinfectant of 1 to 2% of sodium hypochlorite solution, which is having 30% residual chlorine, at least for 20 minutes. Only the treated wastewater can be discharged into drain by the non-bedded hospital. In case of bedded hospitals, they all have to comply to the requirement of the standards prescribed under Schedule 2. That is the as per the Biometric Waste Rules, how the liquid waste generated from hospitals has to be managed. Coming to categories of liquid waste as per Rules 2016 is the one category liquid chemical waste, which says that it has to be stored separately and it has to go for proper treatment. After resource recovery, in case of chemicals, liquid waste, I'm talking, after resource recovery, the chemical liquid waste shall be pre-treated before mixing with other wastewater, or the combined discharge shall conform to the discharge norms. If it is combined with another waste or liquid waste, then that liquid waste has to be treated properly using conventional methods. Then liquid waste compliant to the discharge norms only have to be disposed of. Therefore, these are the various liquid waste generated from hospitals we have already discussed, and I'm not going to. These are the standards prescribed under Schedule 2. Therefore, all the hospitals, the bedded hospitals, and all the hospitals have to comply to the requirement of discharge of liquid waste from the hospitals is they have to comply to the requirement of pH that should be around 6.5 to 9. Whereas in case of suspension solids, it cannot be, the liquid waste cannot have suspension solid more than 100 milligram per liter. Whereas oil and grease cannot be more than 10 milligram per liter. BOD cannot be more than 30 milligram per liter. COD cannot be 250 milligram per liter. And bioassay test, 90% of survival of fish after 96 hours in 100% effluent. Therefore, all these the parameters may become complied by going for physical the processes, but it may not compared to the requirement of BioSA. Therefore, BioSA, if you want to complete the BioSA parameter, all the hospitals have to treat the wastewater generated from the hospital. Then only they can complete the discharge norms. Therefore, as far as the Schedule 2 is concerned, all these limits are applicable to hospitals which are either connected with the sewerage network without terminal sewage plant or not connected to public sewers. Therefore, all hospitals have to comply to the requirement of discharge norms. In case of healthcare facilities, non-bedded healthcare facilities, and then they can go for disinfection of this liquid waste only after disinfection. Then that liquid waste can be discharged by the non-bedded hospital because the wastewater generation by the non-bedded hospital will be very less compared to bedded hospital. Therefore, the method has been suggested for non-bedded hospitals. They can go for simply the liquid waste generated can be treated by the chemical treatment. What are the methods that we can see? These are the all the standards, the healthcare facilities which are not connected with the terminal sewage treatment plant, then they have to complete these standards before discharge into any body, like inland surface water disposal or public sewers or land for irrigation or many coastal waters. They have to complete these norms. This is a must. Therefore, healthcare facilities should have proper treatment facilities. Then only they can discharge the wastewater. Otherwise, it's not possible to complete this requirement. They have to have proper treatment and disposal methods only. These are the characteristics that we have seen in some of the hospitals, somewhere in Faridabad, when we inspected these facilities in Faridabad, Delhi, Ludhiana, and Gurgaon. And these are the characteristics that we have observed. Somewhere very old data, maybe, but most of the hospitals, they are not having any the liquid waste management facilities. Now, it is a compulsory for all the hospitals. And what are the methods available is the hospital wastewater disposal options, the direct disposal. That means no investment is required. They can discharge it, but existing provisions do not permit to dispose of direct disposal. That you have to keep in mind. In case if any wastewater treatment plant is there, method disposal of may be a simple because there are no direct cost is involved. But before disposal of the nowadays, before disposal of any wastewater into the drain also, the liquid waste has to be properly treated. Then only they can discharge. Otherwise, they are not permitted to discharge into what are the various technologies that we can expect should we have there? The Therefore, generally, the wastewater from healthcare facilities has to be divided into two parts. One is domestic sewage and segregated infected wastewater from hospitals. Therefore, domestic sewage can be discharged into a drain. Direct disposal through public sewers or drain is permitted, whereas the infected liquid waste generated from hospitals has to be the treated properly using conventional methods. Then treated wastewater can be discharged into drain so that this water can go for further treatment through the any other methods which are connected with the end of pipe treatments. These are the typical example of the wastewater treatment in healthcare facilities. They can have a bar screen followed by grid chambers and followed by equalization tank. The equalization tank is required in order to make uniform. That's because the different wastewater generated from different wards will have different characteristics. Therefore, all cannot be sent separately into the ETP. Therefore, they all should be collected at one place. They have to mix properly, ensure that it will have uniform quality before it goes for any biological treatment process like active sludge process, that is aeration tank, followed by the clarifier. Then after clarification, the clarifier, the treated water can go for through sand filters or pressure sand filters or carbon filters. Then it will undergo the tertiary treatment process, then chlorine or UV disinfection. Then this treated water can go for discharge into any drain. Then in the process treatment of the wastewater generated from hospitals, you'll be generating different types of the solids, solid waste or sludges like from the equalization tank as well as the clarifier. This sludge generated from these tanks has to go for the aerobic digestion followed by thickener in order to remove the moisture content. Finally, the sludge generated from bar screens and other unit operations are collected, dewatered, then sludge is dried, and this dried sludge, if it is free from all contaminants, then it can be used as a compost or it can go for landfill. If it is contaminated with any other toxic constituents or not compliant to the compost specification, then that waste has to go for the disposal through landfilling only. It cannot be used for the purpose of any as a manure. Therefore, These are the technologies that one has to use for the purpose of treatment of liquid waste from the hospitals. This is the general the flow chart I have shown you, not but it has to be decided depending upon the quality of liquid waste generated by the hospitals. It is the general flow diagram I have shown. But more or less, you will have all these components, and there should be these components in order to ensure proper treatment of liquid waste. What are they? Let us have a look at it. This is the two-chamber septic tank with a line soak pit. It is like a anaerobic process. It is like a simply like a septic tank, two-chamber septic tank, anaerobic process followed by filter unit. Then this is very old method that is followed, and but presently this is not allowed. And in case of non-bedded hospitals, as I told you already, the liquid waste generated from non-bedded hospital has to be treated with using chemical disinfection. Therefore, liquid waste what is generated from the hospital, non-bedded hospitals, can be collected on place, can have the provision of mixing properly. You add the sodium hypochlorite solution, at least allow it properly, you mix it and ensure it is at least treated with for a period of 20 minutes. Then this treated water using the by chemical can be discharged into drain in case of non-bedded. This is the typical example I am showing you in case of the non-bedded hospitals. This is the some of the methods followed in some of the hospitals in the in Bengaluru. As I told, in order to ensure proper treatment of liquid waste, we have to have the disposal through, there are different types of management aspects are there. Disposal through terminal HTP. For that requirement is use of primary, secondary and tertiary treatment, where removal of the bacteria will, more than 95% is bacteria will be there, and treatment of sewage sludge to destroy the ambient eggs to less than 1 egg per liter. Then compliance with local regulatory requirement is a must. Or else on-site treatment of wastewater by healthcare officials, you can have the primary treatment as shown in the earlier slide. You can have equalization tank followed by chemical dosing, flash and slow mixing followed by primary settling tank. After primary settling tank, it has to go for secondary treatment where you remove the dissolved and suspended biological matter using the indigenous bacteria, which is called as activity sludge process or biological treatment process, where generally it contains aeration tank or active sludge process. And after the active sludge process, it will go for secondary settling tank, where all the solids will be settled, and the superintendent will go for further tertiary treatment. In case of tertiary treatment, you'll have pressure sand filtrations or activated carbon filters, where the wastewater passes through the filter units and the wastewater is properly treated and all the contaminants are removed once it comes to the stage of active carbon filter. If you want to remove any of the parameters like TDS, high bearing total dissolved solids and all, then one has to go for RO. RO. RO means a reverse osmosis process. Therefore, where you can remove all the total dissolved solids, it will be free from all the dissolved solids also. Then, before disposal into drain or sewer, the treated wastewater from these filters or active carbon filters has to go for chlorination. You can go, generally we use chlorine or the chlorine powder will be used as a part of chlorination, or you can go for any other technologies like nowadays people are going for UV light treatment, and sometimes they are going for ozone treatment also. This ozone treatment as a part of treatment treatment is a costly affair, where if you want to have the proper safety of the treated water, if you want to consume or something, then you can think of going for the UV treatment or ozone treatment. Otherwise, if you are discharging, generally you can go for treatment by chlorination process. These are the methods one has to follow for treatment of liquid waste from the hospital. Just to have a look at it, I just want to show you, and we will not go into detail. This is the type of bar screen where the removal of all floating matter is possible. Then once the screens are all the screens the floating matter, then the equalization tank where the different types of wastewater coming from different departments in the hospital is collected one tank. Then there will be a proper mixing provision so that all the wastewater becomes uniform in nature. Then this water, and also in order to maintain uniform flow also, not only the quality and quantity wise also, you have to have uniform quantity. No, otherwise these are the proper treatment will not take place. And this is the primary the treatment unit where you will have the chemical dosage. Because of the chemical dosage, there will be a provision of flash mixing, and after flash mixing, the water will go for subjected to slow mixing. Then after in the flash mixing, chemical is what you call it as a flocculation is formed in case of slow mixing, because of you are using the various the chemicals in order to make the particulates, the particles which are in suspended form, will ensure that they come and close and they close and closer because of the chemical dosages. Then when you are going for slow mixing, all flocks are formed. It means the shape of the particles will become more and more, because when they join together because of the chemical actions and slow mixing, they form, they come close and close, they become one big particle. That means that particle becomes enough, the size and the weight is enough to go for settling on its own. Otherwise, they will be in the in a suspension form. Therefore, we use various coagulants. These coagulants will help in formation of flocks in order to increase the size of the particulates, and size becomes such a way that they can settle on its own specific gravity. Therefore, the size of the particles will become bigger and bigger because of the coagulants that we use. And in the process of slow mixing, they come, all these small particles will come closer and closer. They become a big particle, and the size will be such a way that they settle on its own. By specific gravity will be such higher than the water, so that they settle on its own. Therefore, that's why we use the coagulants in order to make the flocks. These flocks, when it go for the next treatment, that is the clarifiers, we say it as settling tanks. When it go for settling tanks, the flocks formed in the flash mixing or slow mixing will settle on its own in the settling tanks. Once this, therefore, these are the type of primary settling tank and secondary settling tank. All the wastewater is the solids are collected here. Only supernatant will go from outlet of the these tanks. And after these setting tanks are the way particles are removed, the wastewater will go for the biological process where the sludge containing the bacteria, which helps in reduction of the oxygen organ matter will be there. They try to reduce the organ matter because of bacterial action, and all this water is sent under the aerobic conditions only. Okay, not in non-aerobic conditions, under aerobic conditions. Then this wastewater is sent for secondary settling tank. The flocks here also the solid which are formed because of biological activity all will settle here. The wastewater free from the less BOD content will go for the tertiary treatment, where this wastewater will go for it will go through various filters. There is pressure sand filters, and here the all the contaminants are removed. And in order to ensure further removal of the contaminants, the wastewater is also allowed to go through the active carbon filters. Here, most of the contaminants will be retained by means of absorption. The typical flow chart for the sewage treatment in the hospitals. This is just, I'm giving you the essence of the treatment plant only, but if you can understand, this is not your science. If you go and observe some of the treatment plants in hospitals, then you can understand easily. These are the biological processes, and these are the hospitals. Some of the hospitals in Gurgaon are having the most of the hospitals. They say they don't have the adequate phase. No, you have to have the treatment system nowadays. The fabricated ETPs are available. If you can in a small space also can have the treatment plant, then it can ensure the wastewater generated from the hospitals. These are the type of the hospital the ETPs that you can installed by the hospitals also in order to ensure proper treatment of liquid waste generated from the hospitals. This is the aerobic processes adopted in the St. John Medical College and Hospital in Bangalore. This is one of the hospitals, HAL hospital, where there is a full-fledged treatment plant. All the wastewater is ensured and properly treated and discharged. Therefore, all the wastewater generated has to, before disposal, has to be treated. Then treated water only has to be discharged into the environment. It may be a drain also, so that you are compliant to the requirements. If you have any questions, you can ask me on the liquid waste management, which you have discussed today, please. Any questions?
Yeah, yes, sir.
Yeah, please.
Sir, actually, I wanted to ask which is mandatory, I mean, for healthcare facility, STP, ATP, both?
See, they are not given easy sewage. You cannot divide where the sewage or the liquid waste generated from the hospital. It's very difficult to divide because of any urine passed by a patient also will contain the contaminants. You may have the bacterial contamination, and even the urine may contain the pharmaceutical residues because he is being treated in the hospital. Then how can you say that the sewage is free from the contaminants? Very difficult. Therefore, I feel so. Liquid waste generated from all the laboratories, it is highly infectious. In from the bathrooms also, whatever the waste generated from liquid waste generated from the hospitals will be contaminated with various contaminants. Therefore, if you want to have if you are having separate provisions, you can have a separate provisions. Otherwise, you can merge both, and you can have one effluent treatment plant. Means it takes care of all the wastewater generated from the hospital. If you mix both sewage and the infectious waste, only the quantum of waste generation will be more. So,
Okay.
the capacity of effluent treatment plant also should be more. So, how to
Uh,
how to segregate the liquid waste which is free from infections or infectious liquid waste, and how to segregate sewage. Most of the hospitals they don't have such a segregation method. Therefore, better to go for one treatment plant combined together, combined wastewater, so that that will be easy for ensuring proper treatment. And before discharge, only one outlet should be there. That outlet should comply to the requirements of as per the rules stipulated under Schedule 2.
Okay, sir. Sir, it's also mentioned in the Biomedical Waste Management Rules 2016, and you have also told non-bedded occupier shall dispose infectious liquid waste only after treatment by disinfection.
Yeah, yeah.
So you have also told that because the non-bedded only disinfection is okay, you said. But then there are two things, 2 points: more than 10 bed and less than 10 bed.
See,
More than 10 bed.
there is a slight confusion, but all bedded hospitals, the whether it is more than 10 or less than 10 bedded, therefore, you take it granted all the bedded hospitals should have to treat the liquid waste generated from the hospitals, and before they discharge into the drain, they have to comply to the discharge norms prescribed under Schedule 2. Whereas in case of non-bedded hospitals, they have been because of wastewater generation will be very less, nominal quantity of liquid waste is generated from them. Therefore, they can segregate the liquid waste from the, especially from the non-bed hospitals, easily, and these liquid waste can be ensured to treat by chemical disinfection using hypochlorite solution, and they can discharge. But whereas in case of all bedded hospitals, whether it's 10 or more or less than 10 also, they have to have full-fledged ETP, and they have to ensure proper treatment before they discharge into drain, and they have to comply to the requirement of the standard prescribed under Schedule 2. Is a must.
Okay, sir. Thank you.
Any other questions? Okay, if no questions, we'll go to the next topic. That may be my final topic that I'm going to discuss. That is relating to the what are the various the international treaties. What are the various international policies that are there concerning waste management that we'll discuss now? I'll take not more than 15 to 20 minutes, but anyhow, we'll try to complete it by 5:30. Can you see my slide, please?
Yes, sir.
Okay. One minute, please. There is a call for me. Want to have a break for 5 minutes? You can have a break, or I will continue. Yeah, Anu Sharma ji, do you have any questions? Yeah, raise your hand, please. Yeah, any questions? Yeah, any questions, ji? Anu Sharma ji, do you have any question?
No, sir, no.
Yeah, raise your hand. That's why I'm asking you. Okay. The slide is visible to you, please.
Sir, I have
Yeah.
one query. Can
Yeah.
sir, can we collected all the waste, water waste from the different hospital, and can we send to the this as a district water treatment plants? Or
Pawan Sharma ji, where are you from?
I am Pavan Mishra. I'm from Kanpur.
From?
Kanpur.
Okay. Please, what is
Haan
your
ji, sir.
diet exactly, please? Can you repeat once again?
Sir, as you said that every hospital needed for the local treatment plant, if we collect it from different hospital and go give it to the some common treatment plant, it is be possible for that or not? It's required for the different plant.
See, common treatment plant is very difficult to have common treatment plant. See, for example, if there is any industry, all industries are located in one industrial estate. Okay, then you can think of going for common effluent treatment plant. There is a possibility because only conveyance is possible. Then you can connect with the one effluent treatment plant. You can go for proper treatment and disposal. But in case of hospitals, it is not possible because the hospitals are not located in one place. Every hospital will have, are located all over the city or anywhere. There is any restriction for the whether hospital should come only in any specific zone. There is no such thing. Hospitals can come anywhere in a town or city, anywhere they can come. There is no restriction. When they are there, all over the cities or all over the city, in such a case, it is very difficult to have a common effluent treatment plant, especially for the hospitals. Therefore, therefore, before discharge of the liquid waste from the hospital, they have to go for proper treatment. It is a must. You cannot, but
Like sir,
depending upon,
safety.
yeah,
Hello.
yeah, depending upon the nature and quantum of wastewater generation and liquid waste characteristics, they have to have their own ATP. You cannot think of going for common ATP. It's not possible in case of
Like sir, safety tank they can be collected and after pre-treatment and then it will be given to the
no. There is
center.
no such thing. There is no
Uh,
such thing, and
okay,
there is no such things are available in the country.
okay,
In case of industries, yes, what is said is possible. See, in case of industries, even for discharge of any liquid waste through a common effluent treatment plant, they have to have the minimum treatment. That is what you call it as primary effluent treatment plant standards. They have to have minimum treatment that any wastewater compared to the inflow characteristics of any CTP, they have to meet the requirement. Up to that, they have to import the proper treatment. Then only that water can be discharged through common effluent treatment plant. Even for sending any wastewater by any industry through a common effluent treatment plant, they had to have minimum treatment facilities and they had to ensure then only the liquid waste which is compliant to that the primary effluent treatment standards, then only that wastewater can be discharged through any common effluent treatment plant. Is it right? Is it okay?
okay, sir.
Yeah. Anybody else? Any questions? This is what I expect. You have to interact. You simply cannot stay like this. I don't like also. Any other questions? If no questions, then we'll proceed to next topic, please. Any questions on liquid waste management?
Sir,
Yeah,
can you explain it in shortly?
regarding. Yeah, you are just joined. Huh?
Yes, sir.
Okay. See, the very difficult to say in very shortly means very difficult to explain everything. All bedded hospitals, whatever the wastewater generated from the hospitals, they have to have their own treatment facilities in order to ensure the comply to the requirement of Schedule 2 standards prescribed under Schedule 2. Okay, they have to have their own treatment facilities and they have to ensure the liquid waste has to be generated from the hospital has to be treated properly, and they have to comply to the standards prescribed under Schedule 2 of the Biomedical Waste Rules. And all bedded hospitals. In case of non-bedded hospitals, there the quantum of wastewater generation from the non-bedded hospitals will be very less quantity. Therefore, the rules have suggested that such hospitals they can collect the infected liquid waste, infectious liquid waste, then that liquid waste can be treated by chemical disinfectant using a sodium hypochlorite solution, like 1 to 2% of sodium hypochlorite solution containing 30% residual chlorine, and at least for 20 minutes, then that treated wastewater can be discharged into drink. This is in a nutshell, if you ask. But anyhow, all the better hospitals that see that what is the quality of the wastewater generated by them, depending upon the quality of wastewater generated by them, keeping in view of the standards suggested under the rules, then they have to have proper treatment equipment unit operations. Therefore, they have to decide what type of unit operations should be there as a part of effluent treatment plant, so that they can treat properly and the treated wastewater will comply to the requirement of Schedule 2 norms as prescribed under Schedule 2 of the Biomedical Waste Rules 2016. That is in a nutshell I told you, but anyhow, better you can go to the course materials given by the IGNO, of course, that is also contributed by me. You will come across all the details in these the course materials also. If no questions, then you can proceed for other this is my last
Okay, sir.
topic, the course which relates to international policies. What are there for waste management in healthcare fields? What are the various international policies which are there for waste management? If no questions, we'll proceed for next topic, please.
Okay, sir, I understand.
Can you see my slide, please?
Yes, sir.
Okay.
Yes,
We all
visible,
know
sir.
waste the hospitals will generate all type of waste, which includes infectious or biomedical waste, municipal solid waste, hazardous waste or chemical waste, used batteries, electrical and electronic waste, plastic waste, construction and demolition waste, radioactive waste, liquid waste, and emissions from boilers, diesel sets, capitals. Therefore, all these sort of waste are generated by the hospitals. In order to manage this waste in the country, we have various regulations, which includes Water Act 1974, Air Act 1981, Environmental Protection Act 1980. Under the Environmental Protection Act only, we have got all sort of waste management rules, which includes hazardous waste management rules, the biomedical waste management rules. Also, we got recycled plastics and manufactured wastage rules, municipal solid waste management rules, and the construction demolition waste management rules, as well as the e-waste management rules and battery waste management. All the waste rules are notified under the Environmental Protection Act 1986 only. Whereas coming to what are the various policies responsible, the environment is responsible for international policies, unprecedented large global environment in order to avoid unprecedented and large global environmental change, climate change, biodiversity loss, and to minimize deforestation and to minimize marine degradation, and to avoid expanding trade and to increase the expanding trade and consumption, and various environmental changes is possible, and these are responsible. And if in order to minimize impact at the international level, there are various international treaties are there, which includes, especially related to waste management. One is the Montreal Protocol. We have got Montreal Protocol, and we have got Basel Convention. Please kindly remember each and every international policy related to what that you have to remember. Definitely can expect one question. Like what is Montreal Protocol is meant for what? What type of waste management? Basel Convention, for what purpose this Basel Convention is there? In order to control transboundary movement of hazardous waste from one country to other country. There is a convention that is called Basel Convention, and there is one more the international treaty or international policy, especially the Stockholm Convention on persistent organic pollution. What is this? And all we'll see. There is a Stockholm Convention, and there is one more is called Minamata Convention on mercury. Therefore, what are these? Let us see. International policies relating to waste management. One is Montreal Protocol. Montreal Protocol is for protection of the ozone layer. Anybody is having about ozone layer? Anybody having idea about ozone layer?
Sir, ozone layer generally protect the ultraviolet rays.
Yeah, very good. Fantastic. What is that is correct, my dear friend? This is the, let's say you have look at my slide. This is the earth where we live on the earth. Above 30 to 40 meters of the atmosphere, above the ground level, above the ground surface, you will find the ozone layer. The ozone layer, which you can see here, this what is the purpose of this ozone layer is whatever the ultraviolet rays are coming from sun, that it filters only the rays which are not harmful to the humankind or living organisms on the earth will be filtered. Only that the rays will be coming onto the earth. Otherwise, it will protect us, the all the life on the earth, from the sun's harmful ultraviolet rays. Therefore, it filters all the ultraviolet rays which are coming from the sun, and only the rays, sun rays which are not harmful to the humankind or animal beings on the earth will be sent to the earth so that we can lead our life happily. Generally, this ozone which will be available in the form of O3, and it will be available somewhere in between 15 kilometers to 30, or it may be extended up to 40 kilometers also. This will be available in the atmosphere, and generally it helps in protecting the life on earth from the sun's harmful ultraviolet. The ozone layer absorbs about 97 to 99% of the sun's medium frequency ultraviolet light, for which will be in the width of 200 nanometers to 350 nanometers wavelength. Therefore, it filters and the ultraviolet light rays which are filtered by this ozone layer, and harmless rays only will be sent to the earth. Therefore, without ozone layer, living on the earth is impossible. This is the international treaty signed in the year 1987. Please kindly remember what is this protocol is meant for. Montreal Protocol is for protection of ozone layer. When this the treaty signed in the year 1987, please you have to remember these points. Okay, when this has been signed in the year 1987, what is the purpose of this? The international policy is in order to regulate the production and use of ozone depleting substances, where there are various ozone depleting substances like chlorine and other things. In order to minimize this production, and this Montreal Protocol has been formulated, and to phase out production of ozone depleting substances. Therefore, the main purpose of this Montreal Protocol is to for protection of ozone layer. This international treaty signed in the year 1987, and main aim of this international treaty is to they regulate the production and use of ozone depleting substances, and also to phase out production of ozone depleting substances. Let us see what is that. What is the next international policy related to waste management is the Basel Convention. This is you have to remember what is the meant for. One is now Montreal Protocol in order to protect the ozone layer, and also to phase out or to control production of and use of ozone depleting substances, to phase out production of ozone depleting substances. Chlorofluorocarbons and all is there. Therefore, now we are all going for the alternates to chlorofluorocarbons. Similarly, the second convention is the Basel Convention. Is in order to regulate transboundary movement of the waste from one country to other. Therefore, to reduce and control transboundary movement of hazardous waste between nations, this convention has been formulated in order to prevent transfer of waste from developed country to less developed countries, and it is also intended to prevent and minimize toxic waste generated, and also the convention has been open for signatures on 22nd March to 1918. These numbers these dates have to remember by you, and what is the purpose of this convention, that you have to remember. That's all, and you can expect at least each and every question from each and every international policy. And also, this Basel Convention entered into force on 5th May 1992. As on date, about 185 countries, including India, are parties to the convention. India also have signed this agreement and Montreal Convention, and where in accordance with the Basel Convention, the various rules and regulations have been formulated in order to control the transboundary movement of hazardous waste from one country to other. See, without approval of any concurrence of any country, waste neither can be exported nor imported. Therefore, with the concurrence of the other countries, only we can import or export of any waste. And generally, the export of waste is not permitted for the ultimate disposal. Only for reuse and recycling only, the waste is permitted from one country to other, not for ultimate disposal. This is the purpose of Basel Convention, that you have to remember. The third one is the Stockholm Convention on persistent organic. What do you mean by persistent organic pollutants? Anybody can say, please?
Sir, please repeat.
What do you mean by persistent organic pollutants?
So like aerosols and bugs and
No.
the
They're nothing but these are the pollutants. These are the pollutants which will be there in the environment for longer duration.
yeah,
For
You can
example,
also say industrial chemicals.
industrial chemicals and
for
no,
example, somebody might have discharged some chemicals, but it will not be there. But it may be transported to another place for longer distance. That may cause impact on longer distance also. Therefore, that pollutants will be in the atmosphere for longer duration. That pollution will be called as generally persistent organic pollutants. Okay, and these are generally the Stockholm Convention generally came into force. There are adopted with the various parties on 22nd May 2001 in Stockholm, that is Sweden, and which came into force with effect from 17 May 2004. You have to remember this. The Stockholm Convention is for control of the persistent organic pollutants. As on date, 180 countries, including India, signed and ratified, and we are adopting this, and we are also trying to follow the rules. And items listed under Annex 38 to the convention, they are permitted for import and export with specific restrictive conditions, whereas items listed under Annex B of this convention generally restrict production and use as well as import or export. And in order to, this convention is there to reduce or eliminate release of unintentionally produced persistent organic pollutant. Means they'll be in the environment for longer duration and they may cause impact. Like pesticides and chemicals like diazepam, mercury, they all will be in the environment for longer duration.
like sulfur from the petroleum products.
Yeah, and India signed this convention, Stockholm Convention, in May 2002, ratified in the year 2006. Since 2006, we are implementing this convention, then in the form of various rules and all regulations, and nation inventory NIP under implementation. Then and also NIP means National Implementation Plan is under implementation. Biomedical rules also prohibits incineration of polyvinyl chloride and introduce emission norms for diazepam. Therefore, diazepam is also a persistent organic pollutant which will be there in the atmosphere, which is generally carcinogenic in nature. Therefore, we are given norms as per as per the commitment made by India in the Stockholm Convention. We are trying to have brought out various rules, which includes in biomedical rules, which prohibits incineration of polyvinyl chloride. If you incinerate these PVC-based waste, then dioxin furands are generated into the atmosphere that are emitted to the. Therefore, the PVC-based waste cannot be incinerated. That is prohibited. And also, dioxin furands limit has been prescribed in case of biomedical incinerators. Earlier, it was not there. Simple example, I don't know, I don't want to explain. This is mercury is one of the persistent organic pollutants. Generally, properties of mercury, chemical forms, volatilization. This persists in the environment for a longer time, and this can generally accumulate in food chain easily by bioaccumulation, and which is toxicity in nature. And mercury is the only element, heavy metal available in liquid form, and it will be available in elemental form or inorganic form and organic form. And mercury in organic form, especially the methyl mercury, is the highly toxic constituent of the mercury. Therefore, generally, this mercury will be converted into methyl form because of the bacterial activity. And generally, these come into the food chain. Once if it is in the atmosphere, because of the rainfall, that will come through precipitation onto the water bodies, and this mercury which is there in the water bodies, that will be taken, that will come into the fish gills. When you consume these fish gills, definitely it will go into join into the our food chain. Therefore, we also will be contaminated. Generally, biomedical waste incinerators or any sludge or any waste generated improperly, all this may cause emissions of mercury into the atmosphere. And when there is a rainfall, the mercury which is there in the vapor form, that will come into the water bodies, and water bodies, whatever the mercury is there in traces, that will reach to the gills of mercury, the gills of this fish. Then when you consume, definitely the mercury will definitely will come into the the bodies of the person who is taking that fish. And it causes the mercury also causes acute exposures to high levels of elemental mercury. It may cause tremors, slowed motor nerve functions, and memory loss. The acute inhalation of high amounts of elemental mercury causes chest pains, acute renal failure, and shortness of breath. Acute ingestion of inorganic mercury, they may cause pulmonary effect like nausea, vomiting, abdominal pains. And if it is a chronic exposure to inorganic mercury, that may cause kidney damages. Therefore, these are the health effects of mercury that you can see. And chronic exposure, what type of problems will be there and all. I think so. It is all not quite. I just want to tell you. It may also cause various impact, like inorganic mercury may cause health effects. Definitely causes various problems if it is. Therefore, health effects of organic forms of mercury is generally it may cause generally methyl mercury is a very toxic nature, and this is the most commonly found in the environment. It is converted from inorganic form by a biological bacterial process. It bioaccumulates into the environment and is most commonly found in fish. Oral ingestion of fish is the most common route of exposure of mercury to humans. Therefore, methyl mercury is also absorbed by the body 6 times more easily than inorganic mercury, and crosses the placenta and concentrates in the central nervous system. Therefore, that is how it damages the central nervous system. In case once if mercury reaches to the humans, various problems are there. Like the mercury, there was the problem called as mercury because of the discharge of mercury. We call it as Minamata. There is a place where this problem occurred in the years 1961, and therefore this is called as at a place called Minamata in Japan. Therefore, this is called as Minamata disease. There was some problem with the discharge of the mercury that caused problems. Coming to this Minamata Convention, this is related to
Sir,
mercury. Yes, please.
sir, can you tell me the exam-related questions about the topics of the mercury?
See, yeah, you see what a mercury is generally, you can say that mercury is the heavy metals which is in the liquid form, which is easily can become vapor at room temperatures. Okay, once if it is vaporized, that vapors, when there is a rainfall, that come and join easily into the water bodies. These water bodies definitely will have the fish. This the mercury which is there as a part of the water body will generally come into the gills of fish. Therefore, fish, when you consume, the humans will affect. This is the path of the mercury I'm telling you. Generally, mercury is generally used in hospitals in case of the mercury-based instruments like thermometers and sphygmomanometers. If there is a if there is a breakage of thermometers or BP operators, then the possibility of mercury discharge will be there. If this mercury spill is not properly collected, then naturally it will come into the path of into water bodies through drains. If it is not properly segregated, then it may cause problem to the mercury is also one of the persistent organic pollutants. Okay, it is also one of the type of persistent organic pollutants. We will have questions after 5 minutes, and I am going to complete this topic within 5 minutes. See, in order to manage the proper mercury poisoning at all, the convention has been there was a mercury poisoning at Minamata in the year 1956, and a globally negotiated international treaty has been initiated in order to address global mercury for the pollution and its serious health damage. And the international treaty and is adopted and open for signatures on 10th October 2013 and entered into force on 16th August 2017. And signed by, as on date, it was signed by 44 countries and ratified by more than 88 countries. Means all not 80 countries have not signed, started implementing, but though they have signed this agreement, Minamata Convention, but 88 countries have started implementing the policies of the Minamata Convention. India signed this Minamata Convention on 30 September 2014. Therefore, and we have ratified in 2016, 2018, but we have started implementing the policies of the Minamata Convention since we have signed. Therefore, various provisions have been incorporated in the various rules for the waste management, especially related to the mercury waste. Therefore, as a part of that only, we have phased out mercury use in number of processes. Like earlier there used to be one the industrial process called mercury-based caustic soda manufacturing. Now we have that eliminated the process in 2003 to 2000, by 2014, and we have eliminated this mercury-based the caustic soda manufacturing units. We have converted to non-mercury-based instrument now. There is a therefore, because of the measures, we have eliminated mercury usage in various industrial processes. Apart from this, we also stopped using mercury-based instruments in hospitals, and also we have suggested various norms in the biometric rules. Like the mercury is also one of the parameter that has been limit has been prescribed under the biometric rules, especially for the biometric waste incineration. As I stated, we have started phasing out use of mercury in a number of processes, including healthcare facilities. Now, in place of mercury-based instruments, India is presently using the mercury-based instruments like digital thermometers and digital BP operators. And measures have been also been suggested, like the dashing for these mercury emissions limit has been prescribed for biometric-based incinerators as a standard also. And waste, in-term storage and its safe disposal has been suggested. Whatever the waste, mercury-bearing waste is dumped there in all the industries that has been collected, stabilized, and disposed through THDF in environmental sound manner. Therefore, no mercury is going to cause any impact in the environment. These are the equipment where the mercury waste generation is there expected from the hospital, where generally thermometers, pygmalimeters, dental amalgam. These are the mercury-based the instruments. Now we are going to non-mercury-based instruments, and there is no problem, no doubt. Definitely, we are shifting. Therefore, effluent discharge norms prescribed for various industrial sectors. Once the India has signed the Minamata Convention, and emission norms for mercury for various industrial sectors as well as prescribed, including biometric incinerators, where the norms for mercury has been prescribed as 0.05 milligram per normal mercury under the Environmental Protection Act 1986.
Sir,
And also, we have come out with the guidelines for the management of mercury waste generated from hospitals, and these guidelines are available. And definitely, you can go through these guidelines, which are available in this website of CPCB, and you can download this. And how to correct mercury and all has been discussed in these guidelines. Coming to international environmental policies, in India, we got various rules are there, which includes hazardous and other waste management rules. Biometric waste rules are there, solid waste management rules, e-waste management rules, plastic waste management rules, lead-acid batteries. These are the waste management rules under the Environmental Protection Act notified by the Government of India. And waste management, the hazardous waste management is concerned. There is a Basel Convention on transboundary movement of hazardous waste, and hazardous waste, because of new chemicals finding way into waste, and cheap diesel options are available, and this has been avoided. As per this, the convention, the waste cannot be imported or exported without any the concurrence from the respective country. And we have got Stockholm Convention on control of persistent organic pollutants, and various guidelines are there. Various the rules have been framed by the Government of India also because India is a signatory to the Stockholm Convention also. India also signed this Stockholm Convention in May 2002 and ratified in the year 2006. And when it comes to the Minamata Convention, it is meant for control of mercury. The main objective is to ban on new mercury mines and phase out of existing ones, and phase out and phase down of mercury use in a number of products and processes, and various control measures need to be taken, including emissions and to air and onto releases to land and water. As a part of this, we have prescribed various standards under the various rules. International regulations of the internal informal sector or artisanal and the small-scale gold mining activities have been suggested. And medical waste management is concerned, where we have prescribed standards for mercury for management of mercury waste emissions from the biometric institutes. Various treaties are there. One is today we have discussed the 4 treaties. That is, one is relating to, one is that you have to remember once again. One is relating to the Montreal Protocol, in order to protect the ozone. This the Montreal Protocol has been framed. It is a part of as a part of international policy, whereas the Basel Convention, in order to control transboundary movement of hazardous waste, this Basel Convention has been formulated, and India is also signatory to this convention. And Stockholm Convention is meant for control of persistent organic pollutants, whereas Minamata Convention is meant for control of mercury from the various processes. This is about international policies. The new necessary to have in-depth the knowledge on these treaties, but you remember what type of policy is meant for what purpose, for what. Therefore, Minamata control, Montreal Protocol is to control ozone for protection of the ozone layer. The Basel Convention is to control transboundary movement of hazardous waste. Means you cannot import or export waste without concurrence of the one country. From one country, you have to have approvals. Then only waste can be imported or exported. But waste will not be allowed to dispose under the Basel Convention. It is a ban. No waste can be disposed or can be sent for any other country from one country for the purpose of ultimate disposal. It is not permitted. Only for recycling is permitted. And Stockholm Convention is meant for control of persistent organic pollutants, whereas Minamata Convention is for aimed at control of mercury emissions into the atmosphere. This is about internal policies, and as far as my knowledge is concerned, I have covered the assigned task to me, as per the best efforts which I have put in. So still, if you have any questions before your examinations, you can ask me on this mobile number, or you can put me on my email ID, your queries, please. If you have any questions, we'll discuss. Otherwise, we'll conclude the session here, please.
Sir,
Yes, please.
sir, can you explain what is the Minamata Convention?
So, I told you, Minamata Convention is to the control mercury emissions. See, various processes which are using the mercury as in the various industrial process, we have to avoid, we have to ban. Like I told you, in case of caustic soda production, there used to be one process called mercury-based process. Now we are banned. Now we are not using that mercury-based processes. Similarly, in healthcare facilities, we are using mercury-based instruments. Now we banned because we are a party to the convention, and we have government of India has made a commitment that we minimize use of mercury and we control mercury emissions into the atmosphere over a period of time. Therefore, we are taking measures to prohibit use of mercury, and mercury process we have the converted into non-mercury based process. Therefore, this is one type of is nothing but use of mercury or the emissions can be controlled. Therefore, in order to minimize emissions, now there is a limit has been set for even for biomedical incidences also. That limit I told you 0.05. You have to remember that limit also. Therefore, convention is nothing but it is an international policy that will be discussed by all the countries, and if they agree, they all sign this agreement, the convention. They become a party to the convention, and based on the commitment made, they say that, sir, we will implement the policies framed under the convention, international policy, like any convention. You take Minamata Convention or any other convention, Stockholm Convention or Basel Convention. As per the policies framed under the international conventions, then we say we agree to the conventions and policies. Then we start implementing that policies in our policies. These are like hazardous rules are there. Therefore, these rules will take care of the control of transboundary movement of goods. Therefore, as per the commitment made in various international conventions by the government of India, that will bring in the form of policies of the internal policies the India. Then we'll try to implement the policies in line with at par with the commitment made in the various conventions at the international level.
One confusion. One question, sir.
Yes, please.
Sir, in the X-ray, there is a radioactive this contrast is there.
No, voice is not clear.
Sir, in the radioactive contrast, which is mixed with some hospital, how we can be segregate and how we treat that?
Which type of waste?
X-ray contrast, MRI contrast.
X-ray counters. It is a liquid form.
Yeah, sir. Contrast means radioactive contrast in MRI or other waves.
See, these radioactive waves for disposal of radioactive waste, this waste does not fall under the purview of the state pollution control boards in the states or pollution control committees in union territories. This, especially the radioactive waste, has to be disposed of in accordance with the Atomic Energy Regulatory Board guidelines or rules. We cannot, that waste will not fall under the purview of the state pollution control boards or pollution control boards or Ministry of Environment Forest. It falls under the purview of Atomic ARB, Atomic Energy Regulatory Board guidelines or their rules. Therefore,
My question is,
for installation of any radioactive based instruments, you have to take approval from the ARB, Atomic Energy Regulatory Board. You have to take approval, and once these diagnosis equipment, radioactive based diagnosis equipment are outdated or no more useful, even that equipment you have to dispose of in accordance with the guidelines issued by the Atomic Energy Regulatory Board. We cannot dispose. Therefore,
uh,
it will not fall under the purview of the state board, but these waste has to be radioactive waste has to be disposed of in accordance with the Atomic Energy Regulatory Board guidelines only. It will not fall under my purview also. Even I cannot suggest. It is not under my purview.
my question is, sir, that if unfortunately it is mixed with water and odor, how we can identify it? It will not be identified.
See, it should be nil. Radioactive should be nil. Then, if you ask me, I can't do the analysis. Therefore, you have to take the help of Atomic Energy Board, their laboratories only, and that waste has to be disposed of in accordance with the. Generally, they now and then they will be testing the wastewater in the drains. They will be testing any radioactivity is there in the drains. I'm telling you,
Yes, yes, I am just looking for this answer.
yeah, Shweta, can you please switch off your microphone? Yeah. Therefore, generally, this Atomic Energy Regulatory Board, they'll be conducting the analysis of various drain samples. Any radioactivity is there? If it is in the limits, they don't have any problem. Okay, man, no problem, no problem. But if they found any concentration of radioactivity, then they alert the concerned bodies to take necessary measures. Okay, generally, anything radioactive waste based things and all, you cannot discharge as you wish. It has to be followed as per the guidelines of certain guidelines to dispose of these radioactive based instruments or waste in accordance with the guidelines. Generally, there will be lead based chamber. Any chamber is there covered with the lead sheets. All the radioactive waste will be kept under this half life till it reaches its half life, and so that you can minimize radioactivity emissions. That is the thing which I've seen in somewhere in Ames. They kept there are some lead bricks are there. All the radioactive waste they kept inside the lead lined chambers where they have stored, and which I have seen long time back. That is the suggested guidance by the ARB. Any waste is there, radioactive waste has to be kept in or stored in the lead-based line, the liner system. That is not going to cause any impact in the environment. But
Because, sir,
you
in most of the X-ray
have to
films,
follow
we,
the guidance of Atomic Energy Regulatory Board guidelines only. If you ask me, I don't have much knowledge on this.
yeah, thank you, sir.
Any questions? Otherwise, we can conclude. No questions. Okay, then I thank you all once again, and
Thank you, sir.
I hope so you enjoyed my lecture. Still, if you have any questions on the topics which I have dealt, you may contact me or you can send me email. I can clarify you. Thank you all once again for your kind patience. And now I request R.C. Bhuvaneshwar to kindly conclude my session, please.
Thank you, sir.
Thank you all. Thank you all.
Thank you, sir.
R.C. Bhuvaneshwar, you can conclude the session. I think so. Nobody is there from R.C. Bhuvaneshwar. But anyhow, therefore, thank you very much for attending this class. Of course, today it is a very good strength I have. Earlier classes are very less strength, but still I have done my best job. If you have still any questions, you can talk to me on about telephone or my email ID, please. Thank you all once again, please. Thank you all.